Hello everyone, my name is Rahul and welcome to my channel DevOps Forge. Today we are going to understand how we can secure, test and validate our infrastructure, and the topics covered are: we will understand how to handle sensitive variables and secrets. Also, we will see some of the given tools which are provided to test and validate our infrastructure. So without wasting any time, let's get started. Terraform manages real infrastructure, not just code. That means whenever you provision your infrastructure, you may have credentials, database passwords, API keys, certificates, or access tokens. And it can accidentally leak if not handled properly. So, one exposed.tf state file can compromise your entire cloud environment. So, security must be built into your variables, right, which you define, and your state storage. For example, you take S3 and you add some restricted policies using IAM, right? And then we have secret management, okay? And then we must have one validation pipeline as well, where we can validate that none of our secrets are getting exposed and we don't have any security vulnerabilities. Okay, so handling sensitive variables in Terraform is easy, and Terraform provides a built-in way to mark variables as sensitive. So inside your variables.tf, let's say you want to define your DB password, okay, which you want to use to log into your database. Okay, so I will say DB password and then I will add the type as string. And the next thing is you want to add a value which is called sensitive, and you must mark it as true so that this DB password will be masked and it will not be exposed in your CLI or in any way, right? But this value can be exposed in the form where you will pass this value inside terraform.tf files, and then you will just commit that terraform.tf files inside your repository. Then in that case, your value will be compromised or your password will be compromised. So what Terraform does? Terraform will hide value in CLI. So you will not be able to output this or you will not be able to see this. Also, it prevents accidental logging and it reduces the risk of exposure, right? So this is one way. What could be the another way? Because the important point over here is secrets are still stored inside state file. So this is not enough alone. Even though you are using this sensitive as true value, but still whenever you just apply the changes, then your state file will include this information, include this password. Then what do we have? So we want to understand the best practices to manage our secrets and sensitive informations, right? So first of all, you must never hard code secrets and instead integrate secret managers. So first point is never, never hard code secrets. And what all options we have in the market for secret managers? First is called HashiCorp Vault. Okay, and this is best when you have a multi cloud setup or you are using some enterprise infra. Okay, and dynamic credentials are needed. Dynamic credentials mean you want to derive the credentials by the capability of HashiCorp Vault and you don't want to create your own credentials, right? So Vault has the capability to generate temporary credentials dynamically. Now, second thing which we have in the market is AWS Secrets Manager. Okay, and we have built-in library, or we can say we have built-in functions in Terraform by which you can call this and also create the secrets manager and add your secret ID and other information, right? You can also provide the policies over there. Okay, so this is best for AWS native deployments. Okay, and if you want to store some credential for RDS or AWS Lambda, right? Now, the third option which we have in the market is Azure Key Vault, and it is similar to AWS Secrets Manager. So we will not discuss more about this, but it works in the same way. Okay, so if you want to see like how we can implement AWS Secrets Manager inside our Terraform code, then you must do one thing. Simply just go to web and search for Terraform code for AWS Secrets Manager. Okay, so the first thing you get over here is this one. Go to the official registry, and over here you can find n number of argument references which you can pass, right? And by this you can define your resource, and it will have a number of policies over here or arguments, right? So you can see this and implement this inside your Terraform code, right? Let's move to the next point. Okay, the second point is we should avoid storing secrets. Okay, we should avoid storing secrets in state files, right? Why? Because we store these state files inside our bucket and we commit this state file, and if you add or if your passwords are leaked into your state file, then in that case you can have some security vulnerabilities. Okay, so state file basically contains what? It contains resource IDs, it contains passwords, it can contain your connection string to the database, right? And your resource metadata. Okay, so if committed to GitHub, by chance, if you commit this to GitHub, then you could have a security breach. Okay, so what are the secure solutions for it? The secure solutions are, let's take an example in AWS, and I would say use remote backend. And we have understood this in lecture 7 that how we can use remote backend, right? And secure backend encryption is the best practice where the recommended backend setups are, we will take an example of AWS, and in AWS we have S3 plus DynamoDB is the best setup to secure your passwords and sensitive informations. Okay, so in S3, what you can do, you can encrypt your data, right? And also you can version it. Okay, you can version it. The next thing you can do is you can add IAM policies to your S3 bucket so that an unknown person or an unauthorized person could not access your S3 bucket and your state file. And then you can add a mechanism of locking using what? Using DynamoDB, right? So this is what we have understand that how we can secure our solution, and in the example of AWS, this is the best way by which you can secure your passwords, your state file, and all of your metadata, connection strings, etc. Right? So moving ahead, what we can do is we will understand the concept of Terraform testing and validation, because this also provide a extra layer of security to your infrastructure code, right? So before running Terraform apply, what you can do is you should always validate your code using some of the commands like Terraform fmt, which means format, and it is used for formatting. Okay, and then we have Terraform validate. This is used for syntax checking, right? And then we have tf lint, which is basically used for linting. And also one last thing is checkoff. So checkoff basically is a tool which can be used for security scanning, right? You can integrate checkoff as a tool inside your infrastructure. You can install this and then you can provide this information or its configuration inside your Terraform code, and it will do the security scanning. Okay, so the first example which we took for FMT is formatting actually does what? It resolves or fixes your spacing issues, your indentations, okay, and also your alignments. Now next thing is uh, so we can understand that this formatting is very helpful when you have the habit of not making a proper indented file, or you have a problem of creating a lot of spaces or adding a lot of spaces or alignment issues. So formatting is very useful in that case, and it can be useful inside your CI pipelines, right? You can add an additional step before you apply, right? You can add this step so that you can format your code properly, right? It can be useful in pre-commit hooks as well before raising any PR or something like that, and also in team environments. Okay, so next thing is the syntax checking, and the command for it is Terraform validate. So this help you to fix your syntax errors, your invalid arguments. Okay, and next thing is if you add some missing providers, right? And it even runs without connecting to cloud. So even if you don't initialize your backend, then also this Terraform validate command will run, and it will check for your syntax errors, invalid arguments, and missing providers, right? So the linter which we have, the Terraform linter, what it does, it basically detects unused unused variables. It also detect deprecated deprecated syntax. Say for example, you were using an older version and you have upgraded to a newer version, and over there you were using some syntax which was deprecated in the newer version. So it also checks that and detects that. Okay, it also help you to check if you have provided an invalid instance type or you did some provider mistakes. Okay, provider mistakes. So the example by which it basically detects all of this information, it provides you the warning, and it can be very helpful in prod pipelines, which means production pipelines. Okay, so let's understand Chekhov. So Chekhov, like I said, is a tool which basically what it does, Chekhov is a static code analysis tool for scanning your IAC files and for misconfigurations that may lead to security or compliance problems. Chekhov scans Terraform for security vulnerabilities automatically, like for example, you have opened any wrong port in security group, right? You have defined your S3 bucket as public S3 buckets, okay, and you have some unencrypted storage, or maybe you have some IAM wildcard policies, which means wildcard policies means you have some loophole by which any person can basically access your infra. And we use this tool by first of all installing it, right? We install it, and then we use checkoff -d dot and whatever your additional arguments are. Okay, so I will do one thing. I will basically go to checkoff official docs. right? And over here, let's see what we have. So this is policy as code for everyone. Okay. Now it says that these are the ISE types which are supported by me, and you can read through it. You can also define your custom policies based on like what are your requirements, and the custom policies can be defined through Python or YAML. Okay. And the compliance has the industry standards. Now let's see what all we have over here. Okay. So one more thing I can do is check off, or maybe what I will do, I will say CKV AWS 20. Okay. And let's see what it is. Now let's see inside this, or maybe let's do one thing, AWS 6. So I will say, what is CKV AWS 6? Right, let me just go through that. Yeah, this is the one which I was looking for. So basically, Chekhov provides you the ID by which it identifies what kind of security mishappenings are inside your infrastructure repository. Okay, so it basically have the ID for, say, if you added your Chekhov tool inside your infrastructure code, what it will do, it will scan your code and it will present some logs, and inside that logs you will see these IDs. Okay, so if you see CKV AWS2, which means what, inside your elastic load balancing something is mishappening or there are some security gaps. Okay, and the policy says that ensure ELB protocol is HTTPS. So this is the policy which defines that what is missing or what is the mishappening going on inside your repository, I mean your infrastructure. Okay, and there are different kind of IDs. If let's say if you have some issues with bucket, then it will throw this error and it will say that you have to fix this, then only you can move ahead. So this is very useful, and like I said, it can be used in, or it can be supported by Terraform, Kubernetes, CloudFormation, your Helm. So this is a very powerful DevSecOps tool. Okay, so we are today not going to take any example code. Why? Because what I will do is basically when I will create a project, okay, in that I will use AWS Secrets Manager as an example, because it will be a very small example if I take an example code right now. And also there are some complications while basically implementing the Chekhov. So for now, let's not take this because we don't have enough information, or you can say enough configuration inside our code. So for that, we'll need to add a lot of codes and lot of, uh, resources, which has to be tied into a proper structure or an architecture, so that we can use the capability of Chekhov and exactly find out what all are the issues. Because if we take a small example, then in that case, what will happen? It will just show you some of them and you will not be able to understand it properly. Meanwhile, these testing and validation commands which you see, you can basically imply that imply this inside your repository, and you can find out whatever mistakes or issues you have created. Okay, you can try and test all of these testing and validation commands by yourself, and we'll meet in the next video. If you like this content, subscribe to my channel, and thank you.